Hi Year 11, this lesson is on solving exponential equations. So the first question here, if we've got x squared equals 9, then we need to take the square root of both sides. So x is going to equal plus or minus 3. Okay, with number 2 here, the first step that you need to do is divide both sides by 5. So then you get n cubed equals 8. And then take the cube root of both sides. So n equals 2. For number 3, a to the power of 2/3. So remember, the aim of solving an equation is to get the pronumeral by itself on the left-hand side. And to do that, we're going to use the index laws. We're going to raise this power, the left-hand side, to the power of 3 on 2. And remember, what we do to the left, we have to do to the right when solving an equation. But the purpose of that is because then you can see, with powers of powers, you multiply the powers, and 2/3 times 3 on 2, the 3's cancel, the 2's cancel, you're just left with to the power of 1. You're just left with a equals 4 to the power of 3 on 2. And 4 to the power of 3 on 2, remember using Ned and his donkey, is the same as the square root of 4 cubed, or the square root of 4, which is 2 cubed, which is 8. Okay, some other examples here. The trick to solving exponential equations when you've got the pronumeral as the exponent or the index or the power is to try and get the same base on both sides of the equation. So change 81 into 3 to the power of something. So 3 to the power of what equals 81? And it looks like it's going to be 3 to the power of 4, just trial and error on my calculator. So now if both of these sides of the equation are equal, that means their powers must be equal. So we can say x equals 4. In number 2, same thing, we're going to try and change these so that they both have the same base. So we can change 25 into 5 squared. Then we can say, since both of these, both sides of the equation are equal and they both have the same base, then their powers must be equal. So 2k minus 1 must equal 2. Then we just have a linear equation to solve. So k equals 3 on 2. In number 3 here, neither of them, we've got to change both bases here. And the base that we're going to change them to is 2. So we're going to change both to 2. So we're going to change 8 into 2 cubed. And we're going to change 4 into 2 squared. Using powers of powers, you can see that's 2 to the power of 3n. And that's 2 to the power of 2. Now we've got the same base, so we can say their powers or indices or their exponents are equal. And then just solving that linear equation. Too easy.